Watch, learn, and we'll be a star freelancer. 24-hour live stream. Save time and money. 100+ free videos and free books with source code, materials, and resources. Starfreelancer.eu.
Welcome back. As part of step 5, we are going to deploy the external DNS. So let's go to our terminal here and we'll enter into the section 08 new ELB application load balancers, and inside that we will go to 0807 0806, which is nothing but deploy external DNS, and we'll say kubectl, and if we want we can verify lslrta and kube manifest. You will find the 01 deploy external DNS.yaml. So I'll say kubectl apply -f and kube manifest. So this should create the or deploy the external DNS for us. So let's wait for it to complete. So we can see here the service account external DNS configured, cluster role, and then cluster role binding created, and deployment external DNS also created. And this warning you can ignore, so that is fine. So now let's come back here and run the command kubectl get all from the new default namespace. So all the deployments and whatever the resources present in default namespace we are going to get here. So we can see here external DNS pod is running, and we can see external DNS related deployment and external DNS related replica set. And if we want, we can also list only the external DNS pod here. So get pods, right? And now you can see external DNS pod running. So if you want to verify the logs, so we can run this command to verify the external DNS pod logs here, and we can see if there are any errors or anything also. We can see here all you can see is everything is working as expected and didn't see any errors here, right? So using in cluster config service token and created Kubernetes client, applying provider record filter, all are info messages. So all are info messages. So there are no errors inside this. So if any errors also, it will be continuously throwing, and then we can easily find it, right? So this completes the deployment of our external DNS related things. So what we have done, so we have created a IAM policy, and we have created a Kubernetes service account with IAM role and annotated that IAM's Kubernetes service account with the IAM role ARN. So all those things we have done using EKS create IAM service account command, and using that single command only for the we have also associated the IAM policy to IAM role. After that we have updated the external DNS default manifest, which will create the external DNS related service account and cluster role binding, and also it has created the deployment which created the external DNS pod. So this Kubernetes manifest, whatever it has created, right, whatever it has provided is from the external DNS related documentation. Ideally, right, already we have created this part, so we really don't need to have this here. We can remove it if we don't want, but I took how the documentation is present, exactly how took it and then put it here. But that's the reason you can see this error also, whatever you are seeing, right, this warning message also came because it is saying that you already have the external DNS and then why you are trying to reconfigure it or something like that. But ideally we don't need this part, but it is given in the documentation. I have added it. So deploy external DNS related Kubernetes manifest. So we already using EKS create IAM service account, we have created external DNS, and we have also annotated that with this respect to IAM role, which means this part here is not needed. So this service account part, but anyway, so it is part of the documentation manifest, so that's the reason I have put it, and which is no harm for us, so that is fine for us, right? So now let's come back, and in our next section or in the next demo we are going to focus on using this external DNS concepts and adding the annotation in our ingress service, and then test it whether our DNS records get automatically created in Route 53 hosted zones. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this demo, we are going to add the external DNS annotation for our Kubernetes ingress service and then test it and then see that whether our DNS records got automatically created by external DNS in Route 53 hosted zones. So let's see the network design once before moving on. So in the ingress service, we are going to add the external DNS related annotations, and after that it is going to automatically add the DNS names in the AWS Route 53 hosted zones, and we'll be able to test those DNS names by accessing them directly in the browser, right? So now let's go back to our GitHub repository and enter into the section 0807 use external DNS for Kubernetes ingress, right? And if you see here, update ingress manifest by adding external DNS annotation. So let's come back here to our Visual Studio Code and enter into the section 0807 use external DNS for Kubernetes ingress, and 010203 Kubernetes manifests for Nginx app1, app2, app3, no changes coming from the previous sections, and 04 ALB ingress SSL redirect with external DNS is the thing which we are going to update here, right? So in this, the name of the ingress service is going to be ingress external DNS demo, and load balancer name is external DNS ingress. And if you come down here, so this is the external DNS related annotation, and inside that we are providing comma separated two DNS names: DNS test 901.stacksimplify.com, DNS test 902.stacksimplify.com. So like this you can add multiple DNSs or multiple subdomains, or even we have provided currently we didn't comment this part, we commented this part so that all the hosted zones will be applicable here, which means I have something called DevOps in cloud. So I can say abc.devops in cloud. So one more DNS will be added with abc.devops in cloud inside the DevOps in cloud hosted zone. See, domain filter, we didn't provide any filter here. So which means all the applicable domains present in hosted zone can be added here, not only stacksimplify.com. So you can use other domains also, because you have commented that option here and said that all the hosted zones present are applicable here to add the DNS entries by external DNS. For now, we are going to test with the DNS test 901.stacksimplify.com and DNS test 902.stacksimplify.com. In addition to that, another important thing here is, so if you need to ensure that this should be yourdomain.com, and also ensure that here certificate ARN also updated with your own certificate ARN in this ingress manifest, right? From your account, whatever the ARN is there, that one you update it. So now let's go back to our GitHub repo and move on to the next step, which is deploy this Kubernetes manifest and then test it. So let's come back to terminal, clear, and come out of deploy external DNS related section, which is 0806, and go inside 0807 use external DNS for ingress Kubernetes, and let's say ls-lrta and kube manifest, just to check that we have all the files 01, 02, 03 and then 04, right? And we'll say kubectl apply -f kube manifest. So this should deploy the app1, app2, app3 related deployment and node port services, and also create the external DNS related ingress service, right? So now this is created. Another important thing here is, the most important thing is, let's keep monitoring your external DNS logs, right? So that we'll get the clarity. Let's wait for it. So we can see here created DNS 901.stacksimplify.com and 902.stacksimplify.com. This is our core goal, to verify that, right? So now let's go to Route 53 and go to stacksimplify.com, and if you see here, DNS test 901, DNS test 902, and if you see the values inside them, right? So this is the external DNS ingress related manifest load balancer service. So 144.863.844. So now let's come back here and go to the EC2 and find the same name here. So let's come back here and go to load balancers, and you should find the load balancer related DNS name, external DNS hyphen ingress hyphen 144.863.844. and here also you will find the same thing, right? 144.863.844, which means the DNS name whatever you have created is associated with your external ingress related DNS name, a load balancer DNS name successfully. So now the next thing here is go and then do the NS lookup tests, right? So let's come back here. So you have verified your external DNS pod with the create. All the things are good. So let's come out and do a NS lookup test for DNS test 901, and it is resolving to the IP address, and also verify for 902, and it is resolving to the IP address. So that is good. And if you want, you can access the application DNS test 901 and then 902. So let me close this IAM, come back here, and DNS test 901 is good, and this is app1 is good, and app2 with DNS test 901 is good, and also we'll access the root context also. So all redirected from HTTP to HTTPS, and everything is accessible with DNS test 901. So now close this tab, and if you want, you can also access with DNS test 902, right? You are accessing the HTTP URL and it should auto redirect to HTTPS, right? You can see the certificate lock symbol here, and app1 is good. And if you want, we can also access the app2 with 902, and that is good. And root context also we can access and then test it. So this completes the verification of using the external DNS with the ingress service, right? And another important thing here is when you are testing it, this should be your domain name. And now we'll go ahead and then clean up this, and it should also delete the 901 and then 902 DNS records. Why? Because if you go back here, right? So if you go back to here, and if you see, you have commented this policy upsert only. So which means it should be in the full synchronization. Whenever you delete your ingress resource, automatically the DNS records updated inside that ingress service, right? Whatever is present inside that in the external DNS related annotation. So those should get automatically deleted. So let's go here and say kubectl delete -f and kubemanifest. And once you delete it, immediately go ahead and then start monitoring your external DNS logs, right? So let it delete, right? Ingress service is getting deleted. So let's wait for the command line to come for us. We'll monitor the logs here, and let's wait for it. Wait for the logs. So you can see create logs you have seen. Let's wait for the delete logs in the external DNS logs for external DNS pod. In meantime, we can go here and then verify if our load balancer is successfully deleted. So this is good. So we need to always ensure that our application load balancer is successfully deleted. By any chance it is present, again it is going to add cost for us. See, now you are back to your external DNS pod logs, and you can see it is having the desired change, which is delete so and so DNSs, and it has deleted those DNSs and successfully updated that hosted zone. So now come back here and go to Route 53 and go back, and again go inside stacksimplify.com, and you should not find anything related to DNS test 901 or 902. So which means whenever you have created the ingress resource, it has automatically created those external DNS records in the Route 53 using external DNS. And whenever you have deleted or destroyed your ingress resource, or you undeployed your ingress resource, automatically external DNS also removed your DNS entries from your Route 53 service. So this completes the external DNS with ingress service demo. In the next demo, we are going to do the external DNS with regular Kubernetes service demo. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this demo, we are going to use the Kubernetes service with external DNS. So which means Kubernetes service of type load balancer, we are going to add the external DNS annotation here. And we are going to provide the DNS name here, and the application whatever you are going to deploy with this respective load balancer service. So you are going to now access it directly with the custom DNS whatever we have created, right? So the Kubernetes service of type load balancer creates a classic load balancer in AWS, and its DNS name will be registered as alias in the Route 53 for the external DNS name whatever you have specified. And whenever you access external DNS K8s service demo.stacksimplify.com, request will come to classic load balancer, and from there you will be able to access your application pods load balanced under this respective load balancer, right? Let's go back to our GitHub repository and enter into the section 0808 use external DNS for Kubernetes service. And if you see here, we are going to create a Kubernetes service of type load balancer and annotate it with external DNS related annotation for a DNS name, right? So, and then deploy and then verify the stuff. So let's go back here, and if you see in 0808 use external DNS for Kubernetes service. So you can see this 01 Nginx is a app1 deployment, right? And 02 Nginx is a load balancer service, which is like Kubernetes service of type load balancer. And here we have added the annotation here, external DNS K8s service demo 201.stacksimplify.com or some 101.stacksimplify.com, whatever it is, right? So now let's go back to GitHub repository and go to step 3, deploy and then verify. So let's go to the terminal here and enter into the section 0808 use external DNS for Kubernetes service and clear, and we'll say kube manifest. We should find the two files here, and kubectl apply -f and kube manifest. So this should create the Nginx app1 deployment and Nginx app1 load balancer service for us. So let's wait for the deployment to get completed. So now let's go back here and go to load balancers here in EC2 and refresh it. So it is creating a classic load balancer for us. So let's wait for this to get created. Currently the status is 0 out of 2 instances is in service. So we'll wait for these things to come into service. In addition to that, we can go back and then verify our external DNS logs in parallel. So let's come here and verify those things. So let's wait for the logs to display. And you can see it has already created desired change, create external DNS K8s service demo 101.stacksimplify.com in so and so hosted zone. So now 2 records in zone stacksimplify.com were successfully updated. So now let's go back here and go to the Route 53 and go to stacksimplify.com related hosted zone, and you should find the external DNS K8s service demo 101.stacksimplify.com. And you can copy this and come here and run the ns lookup and provide the DNS name, and it is resolving to the IP address. So let's wait for this thing like it to come in service. So now it is in service. 2 out of 2 instances are in service. So now let's access this in the browser with this DNS name. So what is the DNS name? So this is the DNS name we have used. So let's take this and put it here, and we are using the app1/index.html. So that is what, right? If you see here, ns lookup is done, and this is the DNS name /app1/index.html, and this is a HTTP URL, right? So simple thing, and your app1 is accessible. So which means we have used the external DNS with the Kubernetes service and it is successful. So now we can go ahead and then delete the kube manifest here. So I'll say kubectl delete -f kube manifest, and once it is deleted, we'll go ahead and also verify our external DNS logs here. So let me go here and get the external DNS logs related command, and let's run this command and wait for the logs. So automatically it need to delete the DNS record whatever it has created. So here you have seen the create related message. So let's wait for the delete related message now. We can see here we got the message delete external DNS, so and so, and 2 records in zone got updated now. So let's go back here to stacksimplify.com, and you should see there is no external DNS related DNS entry inside this, which we have created just now. And also verify if our load balancer, classic load balancer, got deleted successfully, right? So this completes the demo related to using external DNS for Kubernetes service. So I'll see you in the next demo. Until then, bye bye. Thank you. Welcome back. In this section, we are going to implement another important ingress concept called name-based virtual host or host header-based routing. And we are going to implement this concept on AWS application load balancer. So let's understand the network design for the same thing. As usual, we are going to use our 3 applications, app1, app2 and app3. So their 3 Kubernetes deployments and node port services are going to be as is. And in the ingress is the core thing. Inside ingress, we are going to make the changes for our rules. So we are going to define rules with host header based routing. So we are going to define 2 rules. One is app1.stacksimplify.com, which means when host equal to app1.stacksimplify.com, route the request to app1 node port service. From there it will go to that respective pod. And when the host equal to app2.stacksimplify.com, go to app2 node port service, and from there it will go to equivalent app2 pod. And for default.stacksimplify.com, and this is not a rule, so this is directly we will define this related to default backend with external DNS related annotation, and anything you access with default.stacksimplify.com, so it will go to app3 node port service, and from there it will go to app3 deployment related pod. So now next thing here is whenever you deploy this ingress resource, right? So when you define these host rules app1.stacksimplify.com, app2.stacksimplify.com, and whenever you deploy this ingress rules, and already if you have the external DNS related pods running in your EKS cluster, so then it is going to DNS register those domain names whatever you have specified in host also, in addition to whatever you have specified in your external DNS related annotation. So which means in the host rules also you have specified app1.stacksimplify.com and app2.stacksimplify.com. So these two also will get DNS registered in your Route 53 using external DNS. And whenever user accesses app1.stacksimplify.com/app1/index.html, so the request will come to our ingress and then go to the app1 node port service and that respective pod. In same line, whenever user accesses app2, so it comes to app2 related rule in ingress load balancer, and from there it will go to app2 node port service and reach the app2 related nginx pod. And whenever user accesses with default.stacksimplify.com, so request will go to the default backend. So this is called the host header based routing or name based virtual host routing in ingress. And let's see the templates how it is going to look for us. So these are the rules whatever we have discussed so far. So earlier the rules used to start with HTTP, and under HTTP you used to have paths, and you can define multiple paths. That is called context path based routing. And for host header based routing, so it will start with the host and you will define your host whatever you want. Here we have defined app101.stacksimplify.com, and under that with root context whatever comes, go to app1 nginx node port service. So request with app101.stacksimplify.com will go to app1 node port service. And in same line for the requests with app201.stacksimplify.com, right? It goes to app2nginx node port service. So these two are the rules we are going to have with this name-based virtual host routing. And in addition to that, for the default backend you are seeing here, right? So for the default backend, we can directly use our external DNS related annotation, wherein with the default 101.stacksimplify.com goes to our default backend, which is app3 node port service. So this completes the introductory part of Kubernetes Ingress name-based virtual host routing or host header routing. In our next lecture, we are going to go ahead and then practically implement this use case. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go to our GitHub repository, and we are in section 0809 name-based virtual host routing. And as part of introductory section, we already understood about what is this name-based virtual host routing in Ingress. So as part of step 2, we are going to review the Ingress manifest for host header routing or name-based virtual host routing. So let's go to our Visual Studio Code, and we are in section 0809 name-based virtual host routing, and inside that we are in kube manifest folder. And 01, 02, 03 are going to be same from our previous sections, which is app1 deployment and node port service, app2 deployment and node port service, and app3 deployment and node port service. So this is 04 ALB Ingress host header routing. And inside this, so as usual, we will change the name of the Ingress service, which is Ingress name-based virtual host demo, and the load balancer name also we will give name-based vhost Ingress, something like this, whatever relevant name for us when we run the kubectl get ingress. So we'll know the exact demo Ingress service. And as usual, in your demo, you need to ensure that your certificate ARN should be updated here. And when coming to external DNS related hostname related annotation, so I have provided default 101.stacksimplify.com for our default backend, which is app3 nginx node port service. And so if we go down here, these are the important things. So the default thing is completed here, and now we'll move on to the core rules. And under rules, you have something called host, and in host you have defined app101.stacksimplify.com with root context anything comes app101.stacksimplify.com / it should go to app1 nginx node port service, and with app201.stacksimplify.com anything comes with the root context, then it should go to app2 nginx node port service. So these are the rules related to host header based routing or name based virtual host routing, which we have defined here. So now let's go back here and go to step 3, which is deploy all these kube manifests and then verify. So let's come back to our terminal here and enter into the section 08 new, which is new ELB application load balancers, and inside that we are entering into the section 0809 name based virtual host routing. And if we say here kube manifest ls lrta kube manifest, so you will find all the 4 files. In the 4th file is 04 ALB ingress host header routing.yaml. So I'll clear this and run kubectl apply -f kube manifest, and this should create the app1 deployment and node port service, same for app2 and then app3. After that, it should also create the ingress service for us, which is related to ingress name based virtual host demo. So let's say kubectl get pods, and it should display all the 3 pods for us, app1, app2 and app3. Those are running. And we'll also say kubectl get svc, and you can see here all the app1, app2 and app3 related node port services also created. And now we'll go to kubectl get ingress, right? And in get ingress, you should see ingress name based virtualhost demo, and in the hosts here you can see app101.stacksimplify.com and app201.stacksimplify.com. So for this ingress, in the hosts area, you can see it has automatically updated its values. So whatever you have defined as hosts here, so which is this one and this one. In addition to that, you have the standard name based virtual host related ALB core DNS name, right, which is elb.amazonaws.com. So now let's go back here and also verify your load balancer listeners, rules and targets, and before that also verify the external DNS logs. So let's wait for the logs to display, and these logs should show us that it is going to create 3 things for us. So let's wait. See, it is going to create a desired change saying app101.stacksimplify.com is added in the hosted zone as a record, and app201 also added, and default 101 also added. So total these 3 records were added successfully in our Route 53. Also verify that. So we'll go here and go to Route 53 and first verify the DNS records. After that we'll come back to load balancer and verify additional details. So let's go to hosted zones, and we need to go to the hosted zone stacksimplify.com, and in stacksimplify.com, so we can see here default 101 created, and in the same way app101 and app201 also created, and all those things will reference to the ingress service, right? So whatever it is created, so ingress service name based virtual host ingress service with some number 5299 starting with. So if you see here kubectl get ingress, so its name is name based virtual host ingress 5299 something, and we'll go back and also go to our load balancer here in EC2 in load balancers. So we will go ahead and then open this and go to listeners. So this load balancer is in active state, so we'll go to listeners here, and this is the default port 80 listener, which will directly redirect from 80 to 443, because we in our ingress we already have this SSL redirect related setting in the annotations of our ingress, and now we will see the 443 related rules here. And if you see here, you can see when your host is app101.stacksimplify.com, go to app1 nginx related target group, and if it is app201, go to app2 nginx target group. Anything default, go to app3. So now let's come back here and go to the target groups and see if they are healthy, right? So now let's refresh, and you can see app1, app2 and then app3. So app1, if you see, those were healthy, and if you go to app2, so those also should be healthy. And these target groups, you can see your EKS worker nodes were registered with node port services. So node port related information, with that the worker node related instances were registered here. So now let's come back, right, and verify the NS lookup. So the next step here is to access application using newly registered DNS name. So the first thing is verify with the NS lookup command. So let's come back here and do a NS lookup, and it is resolving to IP addresses, and this one also we will try, and it is resolving to IP addresses. App101 also, and app201 also, it is resolving to the IP addresses. IP addresses are going to be same here, and if you want, you can also verify the DNS for your ingress related default DNS name, which is this one, right? So NS lookup, and also provide the this one, and for all these things you can see the IP addresses are same. So now let's come back here and access your application. So app1 you are going to access with app101.stacksimplify.com, and see, this is accessible. And app2 you are going to access with app201.stacksimplify.com. see, app2 is accessible. And default application you are going to access with default101.stacksimplify.com, and you can see default Kubernetes fundamental demo related application is accessible for us. And negative case is with app101 try to access app2 index.html and see what happens. So let's close these things, right, and access this, and 404. Why? Because in app101, which is nothing but your app1 node port service and app1 backend, you are proxying the complete root context, right? So which means in app101 or in app1 there is no app2 related context path with index.html. So from your app1 backend, right, so from your app1 backend you have got a 404 request when you accessed app1.stacksimplify.com with /app2 in the same line. So let's come back here and try for app2 also. App2 try with app1 and it should fail here also. Why? Because in app2 related pod you don't have any app1 related concept or context path, you can say simply. And now if you want, you can also try with default 101 /app1 index.html and app2 index.html. See, and this is also failing. So everywhere it is the same thing. Only with this domain you can go to app2, and with this domain you can go to app1, and with this domain you can go to default pod as of now whatever we have configured. See, all these things are not working. So this completes the name based virtual host routing or host header based routing in Ingress. So now we are going to clean up whatever we have implemented. So let's come back here and we'll say kubectl delete -f kube manifest. So this should delete all the 3 application related deployments, node port services, and also the Ingress service, and also the DNS records created. So to verify that, we'll also put the log, right? So once those were deleted, we'll also let's verify the log now. So let me copy this and paste it here, and in external DNS log we should see all our 3 DNSs whatever registered in Route 53 should be in the delete state. So let's go down. It's opening the log. See, delete app 101 and app 201 and default 101. So now let's go back here and go to Route 53 and verify the same thing. So let me go here and go to stacksimplify.com, and you can see here there is no DNS related to app 101 or app 201 or default 101. So now let's come back here, and our Ingress service, whatever it has created, the application load balancer also got deleted. So this completes the name based virtual host routing demo. And in our next lecture, we are going to focus on SSL discovery related Ingress concept. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to learn about the Kubernetes Ingress concept, SSL discovery with host and TLS. So we are going to implement 2 demos as part of this concept. So now let's go and understand what exactly is this SSL certificate discovery, right? So if you see here, this is SSL certificate discovery using host. So if you see in the rules, earlier we have already implemented the host header based routing. So where you have seen the app 101.stacksimplify.com and app 201.stacksimplify.com were specified in the Ingress rules with host as the argument. So here TLS certificates for ALB listeners can be automatically discovered with host names from ingress resources. So if the ALB ingress related certificate ARN is not specified. In simple terms, when you are using this host header based routing, right? So from these host values, you have given the DNS name here very clearly, app101.stacksimplify.com. So which means you really don't need to provide this certificate ARN related annotation and provide the ARN of your SSL certificate from your certificate manager. So by default, Ingress can directly take the available certificate for these names, which means if the name matches stacksimplify.com, so if you have something called star.stacksimplify.com, so that matches these domain names app101.stacksimplify.com and app201.stacksimplify.com. So automatically it will take that and then associate with your ingress service. So which is nothing but it will associate with your application load balancer. We explicitly don't need to define this certificate ARN annotation. So which is a very good thing that we don't need to go to our certificate manager and go to that respective certificate and get the ARN and hard code that ARN in the ingress service. We don't need to do all those tasks. So automatically it is going to take it with this SSL discovery with host option whenever you are using the host based rules. In addition to that, any other rules, not the host based rules, you are doing the context path based routing, right? So at that point of time, or you are using only a default backend or something. So at that point of time, so it can also use something called a TLS field. So in the next demo, we are going to see the TLS field related demo. So the controller will attempt to discover TLS certificates from the TLS field in the ingress and host field in the ingress rules. So this part you have seen, host field in the ingress rules, you already seen here. And in the next demo, we are going to, in the next slide, we are going to see the TLS field related thing too. And another important note here is you need to explicitly specify to use HTTPS listener with listen ports annotation. And anyway, we are going to do that, and we have already seen in our ingress resources also. So you can see we are already specifying the listen ports 443 for our SSL communication. So we have no issues with this important note. So now let's come back to this demo 2, which is SSL discovery with TLS. So here if you see, your DNS name you have provided as certdiscovery TLS 901.stacksimplify.com. You have something called your default backend, and here there is no host rules here. This is simple context path based routing related example, right? So at that point, when you are using other than host, and then if you want to auto detect your SSL certificate and associate with your ingress service, which means it need to associate with your application load balancer, you can also use this TLS option and provide with TLS hosts and provide your host names here, star.stacksimplify.com. So automatically this related certificate will be associated with your ingress resource or service. Which means whenever we are implementing these SSL certificate discovery in ingress using host or TLS options, we really don't need to have this annotation enabled. So you can go ahead and then comment this certificate ARN related annotation in your both demos. So this completes the introductory part of SSL discovery using host and TLS in ingress. In our next demo, in our next lecture, we are going to practically go ahead and then implement these things. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go to our GitHub repository and implement the demo 1 related to SSL discovery host. So we need to go here, and we are in 08 new ELB application load balancers, and we are in 0810, right, ingress SSL discovery host. And if you see here, as part of step 1, we already understood about what we are going to implement. So we are going to go to this respective ingress manifest and just comment this certificate ARN related annotation. So this annotation will be commented, and rest all is going to be as is from our previous section. And additionally, we are also going to change the DNS names a little bit so that we don't face any Route 53 caching issues. So let's go back to our Visual Studio Code here and go to the section 0810. And these kube manifests are a copy of the previous section, which is 0809 name-based virtual host routing. And as usual, we have the app 1, app 2, app 3 deployment and node port services. No changes in them. So here you will have something called, the name of your ingress service is going to be ingress sat discovery host demo. You can see here sat discovery host ingress. And now if you come down here, so this certificate ARN related annotation is commented here. So earlier it used to be this way, and now we have commented it. And rest all is going to be as is, but only thing is, earlier you have seen default 101, now you will see default 102. And here also you will see app 102 and app 202. So this is to avoid any Route 53 related cache issues, because that demo we implemented just now and deleted them, right? The previous demo. And now immediately we are implementing this demo. So if we use the same DNS names, sometimes due to Route 53 cache issues, you will not be able to access your application. So that's the reason we changed the naming convention a little bit. But as part of this SSL discovery host option, right? So whatever the host present here, it is using some domain name.stacksimplify.com and some domain name.stacksimplify.com. So it need to automatically associate the star.stacksimplify.com SSL certificate from certificate manager to our application load balancer whenever we deploy these manifests, right? So this is 04 ALB ingress certificate discovery host. So let's come here, and the next step here is, right? So the next step for us is to go ahead and then deploy these manifests and then test it. So we'll come out of 0809 and we'll enter into 0810, right? So 10, which is ingress SSL discovery host, and we'll say kubectl apply -f kube manifest, and let's wait for the Kubernetes to deploy these applications, which is app 1, app 2, app 3 deployment and node port service, and also ingress sat discovery host related ingress service. So as usual, we can verify get pods, and app 1, app 2, app 3 should be running, and we'll also see the SVC, which is services. Our 3 node port services should be created, and we'll also verify the ingress service, right? And our ingress service also displayed here. The important thing for this demo is to verify you didn't mention any certificate ARN annotation in your ingress service related Kubernetes manifest. And what we need to do, so we just need to go to our EC2 here and go to load balancers. In this sat discovery host ingress related load balancer, so we need to go to listeners, and you need to verify the certificate associated with it. See, this is the one, right? For the 443 listener port, UR edit certificate. So you can see it has successfully associated the star.stacksimplify.com related certificate. So which, if you want, you can go to ACM and also cross check the certificate. So which clearly states that without mentioning the certificate ARN related annotation with the SSL discovery host option, by default automatically it can check for that certificate present in certificate manager and associate for our application load balancer automatically from our ingress service, right? So now let's come back here. So we have successfully verified this thing, and if you want, you can also verify the logs. So again, these steps are same as our name based virtual hosting, and if you want, you can also access our application and then verify. So you can see here, so let's wait for all the logs to display, and you can see app 102, app 202 and default 102 DNS records also created. And if you want, we can also do a NS lookup test, and that looks good. So app 102, it looks good, and also app 202, and it also looks good. And if you want, you can also access these things from browser, right? So I'll close the certificate manager here, and you can see app 102 with app 1 is accessible, and in the same way we can go here and app 202 we should access the app 2, and it is accessible, and we'll also access the default 102, right? So this should display the default application, which is Kubernetes fundamentals demo. Now let's come back and destroy these manifests or delete these manifests. So this completes the SSL discovery host related things. So without mentioning the certificate ARN, so automatically Ingress can automatically discover the SSL certificate and associate it to the application load balancer using this host value, whatever the DNS name associated here or the host name associated here. So in our next lecture, we are going to learn about the SSL discovery TLS option. So I'll see you in the next lecture. Until then, bye bye. Thank you.